Okay, so we're going to try something a bit more involved this week. So, following on from the kind of overview of the modelling of the roof of the Aviva Stadium, this exercise is based on that project. So the goal is to try and make a volume that represents this roof surface. And rather than do it in the same way that we used on the Aviva Stadium, that involved lots of arcs connecting with other arcs at tangents and connecting to lines at tangents, we're going to use a method that involves making a bit of script and defining a curve, a type of curve called a superellipse. And I think this, if you Google superellipse, you should find a link to Math World, and this describes really how the superellipse can work, and it can basically take many different forms depending on the parameters. This definition in Math World is particularly useful because it gives us a description or a way of defining x and y coordinates, so that we can define these curves. And there's certain types, so you can see here the type of curve, the kind of range of curve types that we can get by changing those parameters. So what we're going to do is we're going to look at how we can take a formula like this and convert it into something that we can use inside Grasshopper. So if you open the file Aviva control, you should see this curve, not very much in that file, and also a couple of boxes in there with some labels. So this is where we're going to see all the section curves before we map them onto 3D. And if you think back to the presentation, you can see this curve is a mapping of the way that the inner edge of the roof changes, the height of the inner edge of the roof changes from north to south and back to north around the stadium. And we're going to reference in this curve, and we're going to use it to control our superellipses. So if you open up a new file in Grasshopper, we're going to jump straight in and look at how we can write a little script to generate a superellipse. And what we're going to use a scripting language which is based on a programming language called C#. If you know Python or VB, you can also write scripts with both of those languages. I've had more experience with C#, so you can find the C# component here under the Math tab, under Script, and then C#. So what we're going to do is relatively complicated, but it's a good way just to jump in and start to see what's actually possible. So if we zoom in on this component, first thing we're going to see is that we've got these plus and minus signs, and we can add more or reduce the number of inputs. So these are our inputs here. So what we want to think about is this definition that we have for the superellipse. We have an A, a B, something called R, and something called T. So there's some, and we're going to get some X and Y coordinates coming out. So let's just think about how we want to set up our scripted component. And one of the basic things we're going to control is how many points we're going to use, or how many points we're going to generate to define the curve. So in this first script variable, I'm going to right click on it and change that name to num points. Okay, so these names are very important because we're going to use them, and the uppercase and the lowercase letters are important as well. So we have to be very precise. Now we also need to tell Grasshopper what kind of data is coming in. So if we right click again, and you can see here that we can choose item, list, or tree. This is actually going to be an item because it's just going to be a number that defines how many points. Because we're talking about points, numbers of points, it's going to be an integer. So we have to describe what type of data is going to come in there. And for the next one, let's put in, let's just call it R for now. And again, this is going to just be a single item. And we're going to make this is now going to be a double. Okay, so number of points and R, and then we're going to hit plus twice, and I'm going to make A, and that's also going to be a double, and I'm going to make this one B. So I'm deliberately using the same parameters that we have in the mathematical definition. So let's go on in and see what we've actually got now. If I double click where it says C#, just need to resize my window a little bit so you can see everything here. So this is the script editor, and really all we're going to do is we're going to put some new lines of script in this space here. So this is our run script. This is what we're defining. You can see here we've got a number of points, a value R, A, B, and then something called a ref object. So these inputs here are the input arguments or the input parameters. Now ref object A is actually going to be the result of whatever we do. So A is going to be what comes out, and if we just click OK here, you can see that we've got output parameter A, something's going to come out, and you can see in the same way here, these are the outputs. We can add more if we want to, so we can have new output parameters. So if we add in another one there, although we only need one here, we go back in and we've now got another output parameter coming through there. So the first thing we're going to do, just to see what happens, is we need a loop. Now loops in programming are a very well used structure, and we're going to create what's called a for loop. So we're going to put in for bracket and then int I equals 0. So we're defining, this is like an integer that allows us to count through a number of loops. So we're defining a counter, and we're going to say as long as that counter is less than or equal to the number of points, and we have to put in the exact spelling. As long as it's less, we're going to do we're going to act on the loop, and then we're going to add 1, which we write as plus plus I plus plus. And so let's just put a pair of, we call these curly brackets. So there's our basic loop, and let's just do a quick check here. So we're going to make a new parameter. We're going to call it's going to be an integer, and we're going to call it count loops. We're going to set it equal to 0, and so for every single loop we're going to say count loops plus plus, and then at the end we're going to make A equal to count loops. So this just gives us a way of just checking or seeing what's going on. So let's click OK. Everything's green. So right now it's just giving us a 1 because we've only got we've got no input here. So let's just zoom out a little bit. Let's add a number slider by just typing in 100. And now let's see what the value of A is. A is now 101. So you can see that this is controlling, number of points is controlling how many times we go through that loop.